Let's take a look at chapter 4 on probability. So probability itself is likelihood or chance of something occurring, of the event occurring. So we're going to take a look at 3 different approaches to find the probability of certain event. We're also going to understand, how to interpret probability values. So let's take a look at some basic definition of the probabilities. First of all, is event. Event is any collection of results, outcomes of the procedure. For example, if you flip a coin, so you basically have 2 outcomes. First outcome is getting a head. Second outcome is getting a tail. Then either one of these is outcome of the procedure, or the collection of the results. And simple event is outcome of the event that cannot be further broken down into simpler components. For example, let's say you roll the dice once, so you get all these different numbers. It's 1, 2, 3, 4, 5, 6. And getting either one of these numbers is a simple event. Okay. And sample space is all possible outcomes, consists of all possible outcomes. All possible simple events. Okay. You can just understand it's all possible outcomes. Alright, so now let's take a look at this example. So let's say we use B to represent a baby boy and then G to represent a baby girl. Okay. And following example, so simple birth, if you have a single child, if you look at single child, one girl is a simple event. Sample space is either a boy or girl. If you have 3 births, then if you want to get 2 boys and 1 girl, it could be boy, boy, girl, boy, girl, boy, girl, boy, boy. They're all simple events. So either one of these is a simple event. And the sample space will have 8 possible outcomes. And next slide, I'm going to show you how to come up with the 3 births. I'm going to show you all these possible, how to construct all the possible outcomes. First of all, so we can have a first starting point. We use this particular method called tree diagram. It looks like a branch of a tree. So this is starting point. I have first birth, you have a boy or girl. Okay, then you go to the second birth. You like the graph look like a tree. Second child, boy or girl, boy or girl. By the time I get a third one, still similar. Boy, girl, boy, girl. Now follow the branch of the tree. Be able to see this, all these possible outcomes. First one is boy, boy, boy. Okay. 3 boys. The second one is boy, boy, girl. Okay, 2 boys, 1 girl. The third one is boy, girl, boy. Okay, and then this boy, girl, girl. Then we get first half of the branch of the tree. And the other half start with the girl, girl, boy, boy. And we have girl, boy, girl. Then girl, girl, boy. And girl, girl, girl. So now we come up with all these possible outcomes. We have 8 possible outcomes. We call this sample space. And the tree diagram is very effective in terms of constructing the sample space. Now, let's take a look at notations for probabilities. P represents probability. A, B, and C represent a specific event. Now, P of A denotes the probability of event A occurring. P of C represents probability of event C occurring. Now let's take a look at basic rules for computing probability. First method is called relative frequency approximation of probability. So we conduct a procedure or observe a procedure and count number of times the event A actually occurs. And based on these results, probability of A is approximated as follows. Probability of A equals number of times A occurred over number of times procedure was repeated. So you can take a look at this. If you flip a coin 10,000 times, okay, this would be the denominator, number of times procedure is repeated. So if we coin 10,000 times, repeat the procedure 10,000 times, and end up with and get 5,000 heads, then the probability of head equal to 5,000, number of times head show up over 10,000. So that turned out to be 0.5. That's why we always look at probability of getting head or probability of getting tail as 0.5. And you can use a relative frequency approach to compute the probability itself. Okay. Second one is a classical approach to find the probability, and it requires equally likely outcomes. So for example, if you roll a die once, then you get this 1, 2, 3, 4, 5, 6, all these possible outcomes, and they have equally likely chance to occur. Assuming that a given procedure has n different simple events, and then each of these simple events have equal chance of occurring. If event A occur in S of this n ways, then probability of A equal S over n. Number of ways A occur over a number of different simple events. So for example, if you look at this, roll the die, you get 6 possible outcomes. And if you want to find the probability of getting an even number, so we know that there are 3 even numbers here, 2, 4, and 6. So the probability of even number should be 3 over 6. 3 outcomes out of 6 outcomes. And turn out to be half. Or you can also turn into 0.5. That's the number. So here, even number could occur as 2, 4, 6. And we have 3 different ways to get an even number over total over the sample space. Sample space is 6 possible numbers. And then subjective probabilities, the probability of event is estimated by using knowledge of relevant circumstances. For example, like weather forecast. It's definitely a subjective probability. It's never 100% accurate because it's subjective. It's based on the professional knowledge about the weather. Second example could be the prediction of California earthquake. That's also subjective probability. Nobody knows when that occurs, but you can only make prediction about it using professional, equipment and knowledge. Law of large numbers, as procedures repeat again and again, the relative frequency probability of an event tends to approach actual probability. So if you look at the case of flip a coin 10,000 times, most likely you will get 5,000 heads. 5,000 tails. So the probability of head will approach the actual probability, which is 0.5. So you get 5,000 over 10,000. That turned out to be 0.5. This is a law of large numbers. So if you repeat the procedure again, you get a probability which is tend to approach the actual probability. Now, when 3 children are born, the sample space, we already show you how to get a sample space. Now I'm going to show you another way of getting this by analyzing all these outcomes. So first, if you concentrate on the number of girls, first outcome getting 0 girls. That means you get all 3 boys. So boy, boy, boy. The second outcome is getting 1 girl. If you look at that, 1 girl, meaning girl could be on the first spot. So you get girl, boy, boy. A girl could be occurring in the second spot. So boy, girl, boy. So you just have to locate a position for the girl. Then you'll be able to get all these possible outcomes. Third outcome will be girl on the third spot. So it's boy, boy, girl. Okay. Second one is 2 girls. That means you only have 1 boy, so we just have to locate a position for a boy. So the location for the boy could be on the first spot, so boy, girl, girl. Could be on the second spot, so girl, boy, girl. Third spot would be girl, girl, boy. Okay, this is third outcome, possible outcomes. Fourth possible outcome, getting 3 girls, so it has to be girl, girl, girl. This is another way to get all these possible outcomes. If you look at it, also 8 possible outcomes. And assuming the boys and girls are equally likely, I find probability of getting 3 children of the same gender, 3 children of the same gender, either boy, 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 or girl, girl, girl. So probability of getting same gender will be 2 out of 8, so it's a quarter. Also, you can write it as 0.25 since it's a well-rounded answer. A simulation procedure is a process that behave in a similar way as the procedure itself is, so that a similar result are produced. Meaning, anytime when you run a simulation, you get almost the same outcome, right? That's the essence of the simulation. Always get a similar result. Now let's take a look at probability limit. So probability is a value, typically between 0 and 1. Okay, you can express as a fraction or decimal numbers. Because probability of impossible event is 0. So let me give you examples. Probability of Thanksgiving occurring on Wednesday. We know Thanksgiving never occurs on Wednesday, so this probability will be 0. So this is what we call an impossible event. Okay. The probability of a certain event is 1. Okay. Probability of event that is certain to occur is 1. So probability of Thanksgiving occurs on Thursday. Thanksgiving always occurs on Thursday, so probability is going to be 1. We call this certain event. Okay. Impossible event and certain event. So if any other event A, the probability of A is between 0 and 1. Always. So probability of A is greater or equal to 0, less equal to 1. So this is possible values for probabilities. We have a certain event which probability is 1, and anything in between we get a likely event. So likely event for probability of A should be greater than 0.5, less than 1. Okay, that's likely event. 50-50 chance, 0.5 as probability. Likely event between 0, probability of A, greater than 0, less than 0.5. That's unlikely event. Impossible event have probability of 0. Okay. So that's breakdown of all the possible value of probability. Complement event. The complement event A is the A bar. It's called A bar. Consists of all outcomes in which the event A does not occur. So if you look at this as sample space, right? I'm using Venn diagram. If this is event A, this is circle in the center, right? And this is the concluded sample space. The event A bar will be here. A bar equal to probability of A bar 1 minus PA. So we use another color. Will be everything else. So this is A bar. This is A. Okay. This color with the circle. A bar should be everything else. Okay, that's a concept of event A and the complement event A. The important thing is probability of event A plus probability of complement event A equal to 1. Okay, this is the most important principle about the complement event. You can also rewrite it as complement event equal to 1 minus probability of A. Okay. Now let's take a look at this example. So 1,010 United States adults were surveyed and 202 of them were smokers. So we know that people either smoke or do not smoke. So that means non-smoker is 1010 minus 202, turn out to be 808. 808 adults do not smoke. So probability of smokers is 202 over 1010. That turned out to be 0.2. Probability of non-smoker will be 808 over 1010. Turned out to be 0.8. If you sum up those two, probability of smoker plus non-smokers, turned out to be 1. 0.2 plus 0.8, that's 1. So run of probability, when expressing the value of probability, you can either use exact fraction or the decimal answers. Exact decimal, right? Could be exact decimal. Or run of final decimal result to 3 significant digits. When the answer is not well rounded, you need to run it to 3 significant digits. So fraction like 2/3 and 5/8. Decimal, exact decimal could be the one we used earlier, 0.5 or 0.25. Okay. Event is unlikely if its probability is very small, such as 0.05 and less. So if probability of A is less than 0.05, then this is what we call an unlikely event. Also, let me give you an example. Let's say you observe 100 newborn baby, and it turns out you have 9 girls and 1 boy. And this 99 girls is very unusually high number of girls, right? You also have unusually low amount of boys. Ideally, we expect to have 50 boys and 50 girls. However, we get 99 girls and 1 boy. Then this event has an unusually low number of outcomes, in this case boys, and of a particular type, or unusually high numbers of girls, in this case of those outcomes far away from what we typically expect. And this is what we call an unlikely event. The probability for this to occur is very low. The probability of this particular outcome will be extremely low.